Hello, welcome back, OpenFoamers and YouTubers, ladies, gentlemen, whoever you are. Welcome to this continuation of chtMultiRegion SimpleFoam. And so in the last video we were doing Allrun pre, and we have taken a look into a little bit of what these are. So let's start with the first part. It's called agglomerate patch faces. So for region in top air and bottom air, so this is a for loop. You will do whatever this is, and this is the end of the for loop, which is done. So run application with the suffix of whatever region it is. Then you have this thing called face agglomerate. Let's take a look at what face agglomerate is. Alright, face agglomerate, this is it. Okay, it says that it will agglomerate boundary faces using the pair patch agglomeration algorithm. So it writes a map of find to cost grid. So it's kind of a mapping thing, and in this case it uses the view factors dictionary to do what it needs to do. So where is this view factors dictionary? The dictionary is in constant, and you can see the view factor dictionary. I think heater. Wait, you have to see bottom air. And you see this view factors dictionary right here. So it's supposed to look for this in the constant. So let's take a look at what the view factors dictionary is saying. And if you didn't know already, view factors dictionary talks about what do you call it? Radiation. So you should be very familiar with what radiation view factors are. So if you're not, please do catch up on this. This is the basic heat transfer radiation. Alright, you need to know what view factors are so that you understand a little more of what this is talking about. So we see this right faces agglomeration is true, and then it will do all of this. End faces in causes level, feature angle, etc, etc. So what we want to do now, okay, I want to all clean everything up, and then we can do an all run and to begin our simulation. So what do you do now? It will do the phase agglomeration on two of the regions, which is top and bottom air. Okay, I'm just going to go through this a little quickly because the radiation bit is not the emphasis yet of these videos. So I kind of want to skip the radiation part till a little bit later and just concentrate on how we can set up, a multi-region case. Hopefully with some conduction and convection. Radiation, we can deal with it a little later. Alright, so for this part, it's view factor generation. So again, this is a radiation related okay, oh, that's done. That's very fast. Okay, let's take a look at phase agglomeration, top air. Let's see what it does. So it'll just agglomerate the patches, top air to heater, top air to left solid, blah 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 blah. And yeah, so we can quit this. We can take a look at the one called view factor generation. Then we can take a look at the bottom air. Now let's take a look at the bottom air. Alright, let's press enter. So it makes these 120 cause faces, for which it will do some of these view factor calculation. Now, yeah, I think the rationale here, again, I'll just go through briefly. Since you're talking about phase agglomeration and you're writing from a fine patch to a coarse fine mesh to a coarse mesh, I think this view factor thing is to, you know, let's say, okay, this was in the last video. Okay, so imagine you have a huge mesh and everything inside emits radiation, right? This is my guess of what's going on. So we have a mesh like this, very fine mesh, relatively fine. So I'll just draw a few more, and there you go. Now, trying to calculate radiation from, let's say, this this mesh, this cell to this, and then this cell to this, and then to every other cell you see in this red line here, red mesh grid, except for the purple line, which was meant to be red, but never mind. That will probably take lots of computation space. So somehow, perhaps the idea was to collect these together, collect these together, collect these together, collect these together, and you go through the whole mesh like that. Okay, and then we'll have some collection. So it's a very rough drawing. It's not accurate. It's supposed to be more even, but doesn't matter. The thing is that you probably have a coarser mesh. All right, coarser mesh here. So instead of calculating from every cell or every face to every other face using the red grid, we can do it using the blue grid with reasonable accuracy. And that's probably what this phase agglomeration might be aiming to do, so that we can generate the view factors, and the radiation algorithm might take less space. So basically this covers the radiation bit. And of course the last one is pretty simple. It's a chtMultiRegionSimpleFoam. So once you set up all the faces, right? Once you set up all the faces, once you set up the case well, what you can do now is that, okay, I want to run this chtMultiRegionFoam, in this case with radiation, and we can take a look at the log. So it's creating solid and fluid mesh for all of this. So that's how it works. Separates it out, and it calculates the thermophysical properties of each of the ones. And then here it's the radiation boundary conditions, boundary radiation model. So it's going to calculate all this, the fluid, the temperature, everything. So once you set up your case right, once you do that, the running of it's pretty simple. Okay, so it's just the setting up of chtMultiRegionSimpleFoam, or chtMultiRegionFoam in general, that's very challenging, because you have to split the mesh up into many regions. And of course, if you want to add radiation, that is another level of complication. I won't go too much into that now, but let's do a touch. Multi-region heater.foam. Okay, I want to open Paraview up, and let's see what this whole simulation is really about. Okay, so this is the usual Paraview opening file. I'll just go to one of my GitHubs, and then I want to look at OpenFoam heat transfer YouTube. So this is multi-region heater radiation. Okay, so all right, let's see, remember there are like 5 regions here. Okay, so we zoom in. Okay, I think we will use a wireframe so it's a little easier to see. Okay, so we have a bottom air internal mesh. Alright, so these are the mesh regions, heater and heater to left solid, blah 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 blah. Okay, so let's take this out and let's see what is the mesh regions we're looking at. So there's an internal mesh. There's an internal mesh for the solid. See how many internal meshes there are. So I'm going to take the heater internal mesh out. I'm going to take the left solid internal mesh out. I'm going to take every other internal mesh except for the main internal mesh. Okay. So, alright, this is the original block mesh that we started with. So that's pretty straightforward. Let's take out the internal mesh. Let's reconstruct it bit by bit. So that's the bottom air part. So let's use solid. It's easier to see, or surface. So the mesh is constructed like this. The bottom air internal mesh. And let's switch back to wireframe. And let's go to heater. Let's see where the heater is. So, alright, the heater is structured like this. We can use the surface, and we use the bottom air internal mesh. Alright, so the heater is like this T-shaped heater. Okay, and then we have the bottom air internal mesh. So the bottom air is at the bottom bit of the heater. Let's see left and the left solid. So this is the left solid. So this is not being heated at all. Wireframe. So there is like a bit which is not being heated. Alright, there's a bit that's not being heated. And then there's a right solid internal mesh also, which is there. And then we have like a top air, which kind of covers the top. So yeah, we could use a different color scheme, of course. That's for another video at least. We can probably use that, but this is just to show where everything is. The red part is the bottom air. The upper blue part is the top air. Okay, the upper blue part is the top air, and yeah, that's about it. Let's take a look at temperature fields, because this will be very interesting. Okay, and we'll use the latest time, because of course, like this is a steady state simulation, or it's meant to be steady state simulation. Let's use the surface. Okay, so this heater is probably a constant temperature boundary condition. We can go and check that in the 0, and then we see the heater. So let's see. See, it's a fixed value at a uniform of 500 for the minimum Y. The rest is all 300. Okay, the rest is all 300. But at the heater to right solid, heater to left solid, yeah. So from that, it kind of diffuses out. Okay, let's see 1800, and let's see the heater, VIT. So yeah, it's 80 cells, and then it's about 500. Okay, so the max Z and min Z, this is a 0 gradient, means there's no heat transfer whatsoever. So I'm going to take out the bottom air just to see the heater which is being exposed. Okay, so as it iterates, you can see the whole thing is heating up. But of course, this is based on iterations. This is not actually, you know, a transient simulation, though it looks like that. But yeah, we can see the heater in the minimum y direction. So we can add maybe we add a data axis grid. Yeah, the heater in the minimum y direction. So at this bottom, it is like 500 degrees Kelvin. And then there's some diffusion going up, and then it will hit the bottom air. So let's see the bottom air internal mesh again. So yeah. So at 600 it's like that. 1800 it's like heated up, but it's kind of a very even heat. Because of course I think it's a steady state simulation, so it's not meant to do very much in the way of doing transient study. So you don't see like those convection currents or anything like that. Okay. But that's basically it for this simulation. Okay, so hopefully we get the basic structure of how to do a chtMultiRegion foam case. First thing first, we do the block mesh to generate a mesh. Then we want to split it into cell sets. Okay, cell sets using a topo set. Then we want to split the mesh regions using the cell sets we created. And then we want to do change dictionary to make sure all the boundary conditions that are between each region, they are being done properly. Of course, it'll be kind of tedious to actually deal with those boundary conditions one by one. It gets a little more complicated, but that's where yeah, you need to do some work. Then after that, if you are doing radiation, you can do this kind of a view factor agglomeration, phase agglomeration, and you generate all your view factors to account for radiation, and then you run your chtMultiRegionSimpleFoam. Okay, so anyway, the other case I kind of want to look at perhaps in the next video. Okay, the other case I want to look at is in the chtMultiRegionSimpleFoam. Okay, not the two-phase Euler foam. I'm not going to look at that. I want to see this Joule heating solid, because this is very interesting. It's talking about a variable internal heat generation kind of a model. So yeah, this is probably one of the cases we'll want to look at in the next video. And we'll want to see, you know, how the case is structured again, and perhaps yeah, we can learn a thing or two about how to make a heat generating model kind of a thing. Okay, all right. So thanks for watching. I'll see you guys next time. Bye bye.